Let's see if we can take a set of data and tell whether or not it represents exponential behavior. So this set of data gives us one pretty nice advantage in telling whether or not it's exponential, which is that the x's are increasing by the same amount. If we look at our x values here, our x values are going up by 5 every time. 0 to 5 is 5, 5 to 10 is 5, 10 to 15, and so on. Our x's are increasing by 5, which is good. So let's see if we can find a pattern in our y's. What's happening with our y's? And when you look at the y coordinates, probably you can see a pattern. And when we're looking for a pattern in an exponential function, we are not looking for addition or subtraction. Addition and subtraction is what we look for in a linear function, where something is going up or down by the same amount every time. Exponential functions don't do that. Exponential functions, we're looking for something that's being multiplied by the same thing every time. So when you look from 64 to 32, you might think, okay, well, 64 to 32 is being divided by 2. 64 divided by 2 is 32. But exponential functions are being multiplied by something every time. Multiplied, which is okay. Dividing by 2 is the same thing as multiplying by 1/2. Now let's see if that pattern is true all the way across. Is 32 times 1/2 equal to 16? Yes, it is. 16 is half of 32. Is 8 half of 16? Yes, it is. And so on. 4 is half of 8, and 2 is half of 4. So all the way across, the pattern emerges that we are multiplying our y's by half every time. So the answer to the question is, yes, this is exponential. Because the x values increase by a constant rate while the y values are being multiplied by 1/2. So that's why they're exponential. The x values are all going up by the same amount, and the y values aren't going up by the same amount because that would make it linear, but they're being multiplied by the same amount, and that's what makes the function an exponential function.